matrix, making use of both the Sirrus rule and the Crammer's rule. In the last class, we talked about dealing with solving for the determinant of a matrix of a 2 by 2 matrix. But in this class, we're going to be talking about solving for the determinant of a 3 by 3 matrix and upwards, actually, how we can make use of solving. Then, we're going to be making use of Sirrus rule and Crammer's rule, like I said initially. For instance, we are given a matrix A such that it's of the form, say, 2, 3, and minus 1. I have 4, 5, and let's say 2. I have 3, minus 3, and let's say 0 here. And I'm expected to use my Crammer's rule in solving this. All I need to do is to denote my determinant, say, plus, minus, and plus. Although we still have the minus, plus, and minus here, plus, minus, and plus here. And anyway you use either of the rows or the columns will suffice in solving for the determinant of the matrix. But conventionally, let's use the first rule like it has always been used. Then you discover that your matrix A, your determinant of matrix A is open bracket, or before that, write your 2, your plus 2, and do not take any number on this column, neither on this row. Then you are having 5, minus 3, 2, and a 0. Then you have minus 3, open the bracket, 4, 3, 4, 3, 2, and what, and 0. Then plus minus 1, open bracket, of 4, 3, 5 and minus 3, 4, 3, 5, then minus 3. Then when I do this, what do I have? Normally, I'm going to be having my matrix A to be equals to, open the bracket, 2 open bracket, 5 times 0 is what? Plus minus, plus minus, plus minus. 5 times 0 gives me 0. Minus 3 times 2 is minus 6 times minus is a plus 6. Minus 3 open bracket, 4 times 0 is 0. 3 times minus 2 is minus 6 plus minus 1 of minus 12 minus 15. Because when you cross multiply, 4 times minus 3 is minus 12. 3 times 5 is minus 15 because of the minus I have here. So I'm going to be having my matrix A to be what? 2 times 6 minus 3 times minus 6 plus minus 1 times what? Times minus 27. So on that note, I'm having my matrix A to be what? To be 12 plus what? Plus 18 plus what? Plus 27 as well. So when I add this up, I have it to be what? To be 57. And when you run through it again, what I did was that I picked a 2 here. I didn't write any number on this column, neither did I on this row. I wrote this. I picked this minus 3. I didn't write any number on this column, neither did I write on this row. I have 4, 3, 2, and 0. Same thing goes with this as well. So I did my simple multiplication of cross multiplying. Then I arrived here. Then my simple stuff of multiplying. Then I equally arrived here. Then I did same here. Cross multiply minus 12. 3 times 5 is 15. Then the minus is here. Then 27 minus 6 and this. So when we did our simple multiplication, we arrive at this with our simple arithmetic. But if I were to go the way of Sirrus rule, it's kind of interesting and simpler to assimilate. Although this is not really hard as well. But how do we do it when it comes to Sirrus rule? When it comes to Sirrus rule, all we need to do is that we're going to be saying that the determinant of matrix A is equals to, I write all of this back, all of them, 3, 5, and the minus 3, minus 1, 2, and 0. Then I repeat the first 2 columns. I have 2, I have 4, and I have 3, I have 3, I have 5, and I have a minus 3. Then I close the bracket. So all I need to do is what? Is to strike an arrow to pick up 3 numbers, strike an arrow to pick up 3 numbers in an upward manner, strike an arrow to pick up 3 numbers in an upward manner and in a diagonal manner. Then I pick my arrow to strike 3 numbers also downward, 3 numbers also downward, 3 numbers also downward. So all I need to do now is to multiply the numbers on the upward rows to be 3 times 5 times minus 1, 3 times 5 times minus 1, minus 3 times 2 times 2, minus 3 times 2 times 2, 0 times 4 times 3 is 0 times 4 times 3, 2 times 5 times 0, 2 times 5 times 0, 3 times 2 times 3, 3 times 2 times 3, minus 1 times 4 times minus 1, minus 1 times 4 times minus 3. So with this, I can easily say that what? The determinant of my matrix A is actually what? Down arrow minus what? Minus the what? Minus the up arrow. In this manner. The arrow that actually came down like this, minus the arrow that went up like this. So on that note, what will I be having? I'm going to need to be having it to be what? Open bracket, 3 times 5 times 6. minus 15 plus, sorry, down arrow I mean to say, my down arrow gives me 2 times 5 times 0 is what is 0, plus 3 times 2 times 3 is what is 18, then plus minus 1 times 4 is minus 4 times this is plus 12, so close your bracket. Then I have a minus, open bracket, 3 times this times is what, minus 15, then minus 3 times 2 times 2 times 2 is what, minus 12, 0 times 4 times 3 is what, minus 0. So at the long run, I'm going to be having it to be what? To be 30, then minus, open bracket, minus 27. So when I do my simple simplification, I have 30, minus times minus is plus 27, then I come out with what? 57. Now that is using what? Your Sirrus rule. We have the same answer like we had it when we did it using Crammer's rule. Meanwhile, if you are to solve for a 4x4 matrix, all you need to do is to repeat the columns 3 other times such that you are having 7 columns now. Then you strike an arrow to pick 4 numbers in a diagonal manner upwardly, 4 numbers in a diagonal manner downwardly. Then your downward arrow will subtract your upward arrow. Then you come out to the answer. Same thing goes for 5x5 matrix, 6x6 matrix. Now, one of the beautiful advantage of Sirrus rule over Crammer's rule personally is that it's easier to use. If you have to compute 4x4 matrix or 5x5 matrix using Crammer's rule, it's so exhausting and your chance of getting an answer is so slim. But your chance of getting an answer using Sirrus rule is high. Short, your likelihood of getting a determinant of a higher matrix using Sirrus rule tends to be what? To be high. Welcome back to class once again. We are going to be talking about the concept of cofactors. We can actually get cofactors of matrices, and I would like to use 3x3 matrix as my own case study, as it is applicable to any other square matrix. But let me submit to you that it is not possible to solve for the determinant of a matrix that is not a square matrix. It's impossible to do that. So before you can talk about the concept of a determinant, it ought to be that you are discussing a square matrix. That is when our point is valid in solving for the determinant of a matrix. All the same, we can solve for what? For cofactor of a matrix. And how do we go about it? It's so simple. I'll use, like I said, I'm going to be using my case study to be what? A 3x3 matrix. For instance, if I have a matrix A, it's so easy actually to be say I have 4, I have 2, I have 5, I have minus 1, I have 3, I have 2, and then I have 0, I have 4, and I have 1. Let's say in this manner. And I'm expected to solve for the cofactor. It's so easy, so easy. All you need to do is that what? Try to do your labeling of a determinant plus, minus, and plus, minus, plus, and minus, then plus, minus, and plus. In short, with this, you are halfway done. So the next thing is get to draw a big bracket. So the cofactor, get to draw a big bracket. I have this big bracket of this form, such that I can then put in it a sub bracket of this manner, a sub bracket of this manner, then a sub bracket of this manner. So this is how I can easily solve for what? For my cofactor of a matrix. So what is the next thing to do? Is that you have a plus, you have a minus of a plus, put the plus here, put the minus here, 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 then fix a plus here. Then all you need to do is to what? Is to solve for their minus. What we call minus. Minus is you actually getting a matrix that is not going to be in the colon of a given number and on that row. And it has no symbol. If you are dealing with a minor of a matrix is not with respect to the determinant, the plus minus. It does not have, it's all positive actually when it comes to the minor. So, but when it comes to cofactors, we need to fix in plus minus plus minus plus minus and the likes of them. So here on this row, I'm going to be having 3, 2, 4, and 1. When I'm not picking any number on this row, not on this column. When I come to this guy now, it's going to be 2, 5, 4, and 1. When I come to this guy now, it's going to be 2, 5, 3, and 2. In that I'm not picking them on this column, not on this row. When I come here now, I will not pick here, I will not pick here. This is what? 1, 2, minus 1, I mean to say, minus 1, 2, 0, and 1. Then when you come here, are you with me? When I come here, I'm not picking any of this row, this column, that is minus 1 is 0, 2 and 1. When I come here, not here, not here, I choose 4, I choose 5, I choose 0, and I choose 1. When I come here, I choose 4, minus 1, 5, and 2. When I come here, it's actually minus 1, 3, 0, and 4. When I come here, it's actually 4, 2, 0, and 4. And when I come here, it's actually 4, 2, minus 1, and what? And 3. So with this, I can easily get my cofactors of my cofactors. So if you just do your simple simplification, you will discover that your cofactor of A is just something simple, your simple simplification, like you're solving for the determinant of a 2x2 matrix, 3 and 2. Here becomes minus 5. Try to compute it for more understanding. Here becomes 18. When you do your simple cross multiplication, then here becomes minus 11. Then here becomes 1. Here becomes 4. Here becomes 8 plus 5 is 13. 8 plus 5 is 13. Then minus 13. Then here becomes minus 4. Here becomes minus 16. Here becomes 12 plus, that is 14. So this is referred to as what? As your cofactors. So although we can, this is referred as a cofactor. Although we can, from that standpoint, say that, okay, then the cofactor of our given matrix A is simply what? Is simply equals to minus 1 raised to power what? M plus 1 of what? Of Mij. What I'm going to say is what? Your cofactor Cij, you understand, is equals to what? Minus 1 raised to power what? Raised to power, let me just say that, I plus j, instead of n plus 1, then I plus j, M, I, j. With this, you can easily solve for, this is actually the formula that coined out each of the entities we have in these matrices that actually formulate to form the cofactor of the given matrix A. Welcome back to class once again. Now we're going to be talking about the inverse of a matrix. The inverse of a matrix. Then how do we solve for the inverse of a matrix? How can it be solved for? It's easy. All we just need to do is to get familiar with the formulas that is backing it up. Now, the inverse of a matrix is denoted by, if you are doing a matrix A, the inverse of a matrix is denoted by A inverse or A complement is actually equals to A inverse. A inverse is the inverse of the matrix, and the adjoint of what? Of matrix A, all over what? All over the determinant of what? Of matrix A. Now the big question is, what is the adjoint of matrix A? Simple. The adjoint of matrix A is simply equals to what? Is simply equals to the transpose of the cofactor of matrix A. The transpose of the cofactor of matrix A give rise, to the adjoint of matrix A. For instance, if you have your matrix A to be what? To be minus 1, 4, minus 2, or minus 1, 2, 3, and 5, minus 1 is 0 and 2, if this was your cofactor of A, then the adjoint of this matrix A would simply be what? Would simply be, you transpose it, 1, 2, minus 1, 4, 3, and 0, minus 1, 5, and 2. And this, you turn the row to the column, the row to column, row to column. With that, you can easily talk about the adjoint of matrix A. That's how simple it can be. Then, and I need to actually let you know that when you multiply a given matrix with its inverse, it's the same thing as multiplying the inverse with that matrix A, and it's liable to give you what? I. I implies your identity matrix. We have actually discussed that identity matrix, which could be 1, 0, 1 is 0, 1 for 2 by 2, and it could be what? It could be 1 is 0 is 0, 0, 1 is 0, 0, 0, 1 for a 3 by 3 matrix. That is called an identity or unit matrix, actually. Then how do we solve for the inverse of a given matrix? How can we go about it? Now it's so easy, and we're going to take an example on that. But we're going to take two examples, one on solving for the inverse of a 2 by 2 matrix, and the second for solving for the inverse of a 3 by 3 matrix. Stay with me in the class. Welcome back to class once again. Now our job is easy. We are giving, say, a matrix B to be, say, we are giving it to be 4, 2, 1, and let's say 3. And I am asked to find what? I'm actually asked to find my B inverse. What do I do? So easy. All you need to do is to remember that your B inverse is actually equals to the what? Your adjoint of matrix B, all over what? Your determinant of matrix B. So how is it solved? It's easy to find the adjoint of matrix B. Actually quite easy. Before we solve for the adjoint of matrix B, can we first of all solve for the determinant of matrix B, so that you just simply cross multiply with your determinant plus and minus on the top. So you'll be having 4 times 3 minus 2 times 1, so that you have 12 times 2, which is equals to what? 10. That's your matrix. That's the determinant of matrix B. Meanwhile, to solve for the adjoint of matrix B, all you need to do is to do what? Is to swap the position of this main diagonal so that you have 3 and 4 here, and you as a result of that, these two entities will be multiplied by minus symbol. So I have minus 2 to minus 1. It's just a simple principle. Swap the numbers of the main diagonal and multiply the other diagonals with a minus symbol. Then you come out with this. Hence, your B inverse is simply equals to what? Is simply equals to 3 minus 2 minus 1 and 4 all over what? All over 10, which as well can be written as what? As this. Then I think I'm quickly on this template, so it's easy for me to prove it to you that when you multiply a given matrix B with its inverse, it's the same thing as multiplying the inverse with that matrix such that it's going to give you a better matrix. Let's quickly prove that here. Now, since our B inverse is 1 over 10, and I have it to be, say, 3 minus 2 minus 1 and 4, and our main matrix is 4, 2, 1, and 3, then let's quickly do our simple multiplication of matrix. And don't forget that when you multiply in matrices, it's actually the rows times the column. So the rows times column, I have 1 over 10 here, open the bracket, 3 times 4 is 12, minus 1 times 2 is plus what? Is minus 2, I mean to say. Then row times column, 3 times 3 times 1 is what? 3 times 1 is 3, minus 1 times 3 is what? Minus 3. Minus 2 times this is what? Minus 8. 4 times 2 is what? Plus 8. So I have minus 8 plus 8. Then minus 2 times 1 is what? Minus 2. 4 times 3 is what? Is 12. So at the end, I have 1 over 10, open bracket. I have 10, I have 0, I have 0, I have 10. So at the very end, what do I have? I have 10 over 10. 10 over 10 is 0 over 10, 0 over 10, 10 over 10. Hence, it becomes 1 is 0, 1, and it's giving me what? A unity matrix. So it's actually proven that when you multiply the inverse of a matrix with itself, it's same as multiplying that matrix, that inverse of the matrix which is inverse, and it gives you an identity matrix. But when dealing with a 3 by 3 matrix, for instance, if you are given a matrix C to be what? To be, let's say 2, let's say 1, let's say 3, let's say minus 1, let's say 4, let's say 3, let me say, okay, minus 2, let's say 1, let's say 0, let's say 1. Then I'm asked to find solve for the inverse of this matrix. What am I going to do? Let's quickly solve for the adjoint of this matrix, which is easy to do. So the adjoint of what? Of matrix C is given as what? As here is actually 4 times this is 1, is 4. So I have 4 here because this one becomes a 0, and I have a plus. Then when I come to this place, I have 1 times 1 to be what? To be 1. 3 times 0 to be 0, that is minus 1, because I actually have a minus here. Then I come here again, and I say minus 2 times 1 minus 2, and 3 times this is 12. So minus 2 minus 12 is minus 14. So I have 14 because there's a minus here. Minus plus, don't forget, plus minus plus, minus plus minus, plus minus, and a plus. So, but when I come here, I have it to be minus 1 times this is minus 1, minus 2 times this will give me plus 2, minus 1 plus 2 is 1. So I have minus 1. So when I come here, I have it to be 2 times is 2, 3 times is 3, 2 minus 3 is minus 1, so I have it to be minus 1 as well. So when I come here, is 0, I have it to be a minus actually. So when I come on this row, on this column, that is 2 times minus 2 is minus 4. Minus 4 plus 3, that is minus 4 plus 3. Sorry, are we together? I come here, minus 4 plus 3 is minus 1. And there's a minus here, so it becomes a plus 1 actually. So when I come here, I'm picking these two numbers. So I have a 0, I have 4, that is minus 4. We have done that before, so I want you to verify it. That's I'm trying to solve it here. And minus 2, I have it to be 2 times 0 is 0. Then minus 1, no, 1 times 1 is, so I have a minus 1 here, but it becomes plus 1 because it's a minus on the top. So I have a plus 1 here. So when I come here, I have 2 times this is 8. Then I have 1 times minus 1 is plus 1. So 8 plus 1 is 9. So I have it to be 9. So I've just simply found my adjoint of C. My cofactor, please, pardon me. My cofactor of C. So to find the adjoint of what? Of C, what will I be having? I'm going to do what? I'm going to be transposing this. So I have it to be 4 minus 1 and 14, minus 1 and 1, minus 4, 1 and what? And 9. So that is actually the adjoint of C. So the next thing for me to solve now is the determinant of matrix C. So that what will it give me? I have my 2, I have 4, minus 2 is 0 and 1, minus 1, I have my 1, 3 is 0 and 1, then I have my 1. Don't forget this is a minus 1, so here is actually a minus 1 in the bracket, so you have to be very careful with that, plus 1. So I have 1, I have 3, I have 4, and I have what? A minus 2. I hope you are still with me. So on that note, you can easily say that what your determinant of C is equals to 2 open bracket, 4 plus what? 4 plus 0 by cross multiplying. So I have a plus 1, I have a 1 minus 0 here as well. I have it to be what? Plus 1 minus 2 minus what? Minus 12. So at the end, I have 2 times 4 plus 1 times 1 plus what? Plus 1 times minus 14. So I have 8 plus 1 minus what? 14, which equals to what? Which equals to minus 5, actually. So that is actually my determinant of matrix C. Hence, my C inverse is equals to what? The adjoint of matrix C all over the determinant of what? Of matrix C. So I have man over minus 5, open bracket, 4 minus 1, 14, minus 1 minus 1, 1, minus 4, 1, and what? And 9. With this, I successfully solve for the inverse of my matrix C. So far so good. I've been able to talk about the adjoint of matrix C, inverse of matrix C, Sirrus rule and Crammer's rule in this class. So by God's grace, in our next class, we're going to be looking at how we can easily apply the concept of matrices in solving simultaneous equation, especially. And it's also applicable when you're trying to solve for eigenvectors and eigenvalues, eigenvector and eigenvalues actually. So, but till we meet again, please ensure that you click the subscribe button, share with family, and don't forget to share alongside with friends. And also drop a comment. It will go a long way to give us a feedback on how we can get better. Thank you.